So guys, once again welcome back to Ahoy Navigos. We are continuing our concept of trim type A problems. Today we have in front of us type 5 problems of trim to find HF. So the question is, a ship of LBP 130 meters and MCTC 175 ton meter draws 7.2 meter forward and 7.8 meter aft. 1600 ton of cargo was loaded in number 2 lower hold, HG 30 meter forward and 1400 ton in number 5 lower hold, HG 55 meter aft. Drafts were then found to be 7.8 meter forward and 10.4 meter aft. So we need to find our HF. First of all, we know the initial drafts, we know the final drafts. So do one thing, let's go to our table, let's put in the drafts. Initial drafts forward 7.2, aft 7.8. Final drafts forward 7.8 and aft 10.4. We have our equation as we know. So if you know the initial drafts and final drafts, we can get our initial trim. That's initial trim is 7.8 minus 7.2, 0.6 meters, and final trim is 10.4 minus 7.8, that's 2.6 meters. So if you know your final trim and you know the initial trim, you can get the trim cost. So we can say the trim cost is 2.6 minus 0.6, that's 2 meters. If you know trim cost, you know trim cost is always in centimeters. So this 2 meters will become 200 meters. And the trimming moment equation is trim cost in centimeters is equal to trimming moment divided by MCTC. We know, because we know all the equations, trim cost is equal to trimming moment divided by MCTC. So from this we can say trimming moment is equal to trim cost in centimeters into MCTC. That's 2 meters will become 200 centimeters into 175 as in question MCTC. So we can say 35,000. That's your trimming moment. So next thing, we know the whole trimming moment when we have two weights, that's 1600 ton cargo and 1400 ton cargo. The whole trimming moment will be W1D1 plus W2D2. And let us suppose we don't know the distance of center of flotation from aft perpendicular, or we don't know it from the midship also. So we need to consider, let's consider COF abaft H and the value as X. We are just supposing that our center of flotation is abaft H. That's what we need to find, how many meters it is. So we are just supposing it's X distance abaft our midship, that's H. So we can say your center of flotation to center of gravity of number 2 lower hold is 30 plus X, because since your center of flotation we are considering abaft midship, and you know in the question number 2 lower hold it said 30 meter forward of midship. So it will be 30 plus X, and the trimming moment will be by head since we are loading forward. Similarly, for the center of flotation to center of gravity of number 5 lower hold, it's since it is 55 meter aft of midship, and we are supposing our COF X meters aft of midship. So we can say it is 55 minus X, and since we are loading aft, it will be causing a trimming moment by stern. So since we have both the distance, we know the W1 and W2, that is 1600 ton and 1400 ton in question, and we know the whole trimming moment, that's 35,000. So we can write the equation as trimming moment is equal to W1D1 minus W2D2, since one is number 2 lower hold, that's by head, and the other one is number 5 lower hold by stern. So both are different. So we can say we are just subtracting both each other. So we can say W1D1 minus W2D2. Next thing what you need to understand in these types of problem is you need to take whichever side first. Like whichever weight you need to take first, the forward one or aft one. Answer to that is side on which F is considered to be taken as first moment side. That means since we are considering our COF X distance abaft H, so we can say your side astern or the loaded at the stern part to be considered as W1D1, that's 1400 into 55 minus X, minus W2 is 1600 into 30 plus X, that's equal to 35,000. So we can say the equation as 77,000 minus 1400X. We solve this brackets, we will get this way, and finally we can say minus 3000X is equal to 6000 and X is equal to minus 2 meters. So what does this minus indicate? This negative states that our assumption was wrong. What we assumed before was COF is above H. So the negative sign indicates that assumption was wrong, and exactly what in reality the H to our COF is forward of our H. That means it's forward of H by 2 meters. So that's the answer. We can say HF is equal to 2 meters forward. So guys, this is how we do to find HF type of problems. So now let's go into our next type of problem. We have a table, blank table, and this is type 6 of problems, and the type are load keeping draft constant. So let's see. So the question is, a ship 160 meter long has MCTC 200 ton meter, TPC is 30, and HF is given as 3 meter aft. Draft forward is 6.8 meters, aft is 7.8 meters, and we are asked from where may W, let's say weight, tons be discharged such that the draft aft remain constant. So we know our initial drafts 6.8 and 7.8, and we know our final aft draft that's same as your initial draft, that's 7.8. So let's go into our table. So we can say, you know, initial draft 6.8 and 7.8. Also in question it is given that after the operation of W tons being loaded, your aft draft should be same. That means your initial aft draft and final aft draft should be same. What does this mean? This means that we know from the table 7.8 plus mean sinkage or ICH plus T over TF, that should be your final draft, sum of these three. So if you want to get your initial draft as your final draft, this mean sinkage or TA and TF, sum of these should be equal to 0. That means your mean sinkage or ICH should be equal to your TA. Since it's aft, it is TA. So we can say, let's get into first thing. So that's our concept, and first thing what we do as usual, HF, since it's given 3 meter aft, we can say AF is equal to LBP by 2. Since it's 3 meter aft, you can say minus 3. So it's 160 divided by 2 minus 3, 77 meters. Next thing, W by TPC into 100. Since I said in table, you know, this mean sinkage or IC should be equal to TA over TF, then only that value will be 0. So you can get initial draft is equal to final draft, and your aft draft will be constant as your initial draft. So we can say this is equal to this. That means W by TPC, that's W by 30. Since in question it's given as TPC is equal to 30, that's always in centimeters. Since TPC is in centimeters, ton per centimeters. Next thing is our TOTF, and that's TA. And the equation for TA, we know AF by LBP into TC. So let's see our equation. So we can say W by TPC into 100. Since it's in centimeters and everything else always in meters, we convert whatever in centimeters into meters. So since in the case of this TPC, we can say W by TPC into 100 is equal to TA, and the value of TA we know AF by LBP into TC as from the equation before we know. So we know the value of AF 77, we know the value of LBP 160, we need to find TC. So what is TC? TC is our trimming moment divided by MCTC in centimeters. So MCTC in centimeters, the values are trimming moment is equal to, you know, W, since only one weight is we are loading and we don't know the distance. So what you need to find from this equation is this D, and the MCTC we know it's given in 200, and MCTC is always in centimeters. So whenever you want to convert that centimeters into meters, divided by 100. That means the equation for TC will be WD divided by 200 into 100 meters. So now you know TC. So let's apply that into your equation of TA. So the total equation will be W by TPC into 100. That's TPC is equal to 30. That's 30 into 100 is equal to 7 AF by LBP into TC. That's TA. So AF is equal to 77 divided by 160 into TC we already found, it's WD divided by 200 into 100. So in this equation you can see that W and W is common, you can cut it out, and you can see 100 and 100 is common, you can just remove it for your easiness. So in this side it will be 1 by 30, and this side it will be 77D divided by 160 into 200. 77D divided by 160 into 200 is equal to 32,000, and the other side you have 1 by 30. So you can find the value of D from here easily. That will be 32,000 divided by 30 into 77, and the answer is 13.85 meters. So that is the value of D. So that means this is the distance at which you need to load our W tons to finish our aft draft as same as your initial aft draft. So that means this is your answer. So this is how we solve our these types of problem. In this case, nothing but if you want to remind your aft draft as constant, your mean sinkage or icage should be is equal to your TA or TF. That means though both cancel each other and become 0, so that your initial draft is your final draft. So this is how easily you can solve these two types of problems of trim. I hope you guys understood. If you have any doubts, put in comments, we will get to you. Stay tuned to Ahoy Navigos. We will be coming with more types of trim problems. Thank you.